one example, and the examples throughout will in this talk will be about images. And the example over here is of an image, which on the left, which you see is a original image. And even when you use just 29 principal components of the original image, you are able to get a fair approximation of the original image. And this is what makes the machine learning algorithms can make use of only just these 29 principal components and do the algorithms and the processes. And so you're reducing the data that is needed for this algorithm to work upon, and thereby decreasing the load. Another data reduction technique, data dimensionality reduction technique would be singular value decomposition. Now, singular value decomposition is actually a matrix factorization form. And here our matrix is the image itself, and the matrix A can be decomposed into decomposed into products of three matrices: U, sigma, and V transpose. And this sigma is also known as the singular valued matrix, which is actually a diagonal matrix which contains the highest singular values of this particular matrix that we have A. And in this example, this is the original image that we have. That is a image that contains all the 499 singular values. And even in a value between 20 to 50 singular values, a machine learning algorithm can actually figure out what it is and use it for maybe object detection or classification or whatever the purpose of the algorithm is. So the basic idea is we reduce the dimensionality of the data from a very higher space to a lower space for ease of performance in the machine learning algorithm. Now, the next part is would be a bit mathematical on what tensors are, and some of the properties of tensors that we would need to understand what is HOI and the algorithm behind it. So we'll move in this format as shown in the slide over here. And let's see what tensors are actually. So tensors can actually be classified as an n-dimensional array. And a 1D tensor is a vector. A 2D tensor can be written as a matrix, and a 3D tensor is a cube, as well as a 4D tensor. If you want to go in higher dimensions, a 4D tensor can be denoted as a vector of these cubes that we have over here, and a 5D tensor as a matrix of these cubes. So the first thing that we need to know is an inner product, which is very similar to the vector product or the matrix product that we do. And we multiply each of the subsequent elements in a tensor A with the another tensor B. And here we have a third order tensor multiplied with another third order tensor. Now, extending this idea for tth order tensors, we have the inner product between two tth order tensor A and B. And we introduce this idea of Euclidean norm in the Euclidean space into the tensor space that we have. And this is the notation for the Euclidean norm. This is a particular condition that we need to minimize in the higher order orthogonal iteration algorithm. So this particular Frobenius norm it can be used as a measure of the distance between two tensors A and B. Now, the next thing that we need to know for this jargon is one is order and the other thing is mode. The number of dimensions is called order, and each dimension in the tensor is called a mode. So you can see the number of the order of the tensors mentioned over here, and each of the dimension is called a mode. And now what we need to know is that a particular notation that we are going to use, we'll use mode n to denote the nth mode. And this small letter u, bold small letter u with the superscript denotes a particular mode of a vector, and this capital letter U with the superscript will denote a particular matrix of the vector. And now we look at what are mode n vectors and what are mode n slices. Now read through the max as well as I explained to you what is a mode n vector. You take a particular tensor and you slice it in two of the other dimensions that you need. For example, you take this 3 cross 6 cross 4 matrix, and in the I1 and I2, when you slice it in the I1 and I2 dimension, you get this this kind of arrangement of the tensor. Whereas when you slice it in the I2 and I3 dimension, you get this arrangement, and in the I3 and I1 dimension, when you slice it, you get this arrangement of the vectors. And in the same way, you can do it for to get a matrix. You just slice it in just one of the dimensions, and this would actually denote the mode n slices. And this would be a modern matrix. The previous one was being modern vector. Now, what we do after slicing is that we unfold this matrix. Unfolding is actually also known as matrix transformation or flattening. And what we do is that we take a particular mode and we stack it one by one beside the other. So this is actually a mode one stacking of a tensor A, which is of the dimension 8 cross 6 cross 4 into a matrix of the dimension 8 cross 24. Now you can vectorize it if you keep all these stacks one by one below the other, and you would get a 192 cross 1 matrix or a 192 dimension tensor. A 192 dimension vector. And the modern product, as shown earlier, a modern product denotes the nth mode of the product A, nth mode of the tensor A with the matrix U. And U in our use case will also always be a orthogonal matrix. And this is what is the notation over here. A mode and product means that you multiply a particular nth mode of the tensor A with a matrix U. And this is a visualization of a modern product. You take a particular tensor A, you convert it into the mode that you want. Over here we have the first mode, and then the you multiply it with a matrix to obtain a smaller tensor B, which is the product of this tensor as well as this matrix. Product of this tensor's first mode and the matrix. So these are some properties that you can review when you want later on the algorithm that will be used in the higher order orthogonal iteration algorithm. Since yeah, a lot of math is over, we'll just go to, and I'll show you what is actually how powerful this HOI algorithm is. This is the original photo or the picture that I have, and even just by using 1/100th of the original features, I'm able to faithfully reconstruct an image from the original image, and this image can actually be used in a variety of purposes. Even if when I use 20% of the original features, I'm able to get almost the same image as the original one, but the feature space is reduced as well as my dimensionality is reduced. And this is what is the work of how higher order orthogonal iteration changes the data. And this is the algorithm. Now, basically, this is the algorithm that has been implemented in the code that will be providing you in the end. But what actually happens is that this original matrix, original tensor M is being approximated as a smaller tensor B, and for three orthogonal matrices over here, L, R, and B. So this is the basic idea. We convert this large tensor M into a product of a small tensor B as well as the product of these three orthogonal matrices. Now, getting to what higher order orthogonal iteration is, it is an iterative algorithm. As you have seen earlier, it's a iterative algorithm. And what it does is that it minimizes this condition. It minimizes the fogginess norm between the original image and the image that you are getting in the final end. And this is actually the first mode multiplication with the first orthogonal tensor or orthogonal matrix, the second mode multiplication with the second orthogonal matrix till the third order orthogonal matrix. And we minimize this condition, and the optimal B, as you can already guess, this is the optimal B that that we can have. And what we actually do is that we successfully solve this restricted optimization problem, and we minimize a particular UP, keeping all the other U1 to UT constant. That is what is being done in this format. And this has been demonstrated earlier in this algorithm part. Over here on the iteration part over here, and how it is being iteratively solved. And we keep one of them constant, and we keep all of them constant, and explicitly solve for just the UP. And you can generalize this into higher dimensions. And the application that we have is that we reduce the storage from I times j times k into a very smaller number, that is written over here. And this is a small number, as I say, because R1, R2, and R3 are very, very small numbers compared to J, K, and I. And not only the memory is safe, but the algorithms that we use can also converge quicker while we reduce the dimensions. And as you know, this can be used in classification problems as well as regression problems for the dimensionality reduction. And that's it. This is the reference paper of higher order orthogonal iteration. And this is a multilinear subspace learning book from which I have referred many of the images. And this repo, you can go to this repo and see for yourself the working of the code and all the images that I have shown in the demonstration slide. And that's it. Thank you.
Okay, Dan. Have you come across any specific performance analysis of this PCA, SVD, and this HOI? Like
Yes, ma'am. Yeah, like this can be directly compared like SVD, but there is another procedure called higher order singular value decomposition, or HOSVD, and there is a performance matrix which shows that HOI is better than HOSVD in all scenarios. Like the code, if you see the code from which I have referenced the HOI code, it's there in the GitHub repo.
Can you? It's basically doing SVD, right? The algorithm.
In the algorithm part, yeah, there's this SVD component that comes in. Iteratively, we do it. That is why that iteration part is over there.
Yeah. What about the use case in bioinformatics? Any specific application where you will be using this?
And then that aspect is actually where I'm not in that domain, but bioinformatics is where you have like maybe hundreds and hundred thousands of dimensions, like in genetic and genomic data. And when you want to reduce this dimension, like for whatever purpose of TSME or other visualization factors, you can actually use this as a pre-processing step. That is what I meant by that. In bioinformatics, this is you can apply it in all domains where you want to reduce the dimensionality of the data that you have.
Okay, that's all from my side. The presentation starting from the intro of tensors and all. Now, any questions from the audience?
May I ask you a brief question? I would like to know how you will physically interpret principal component analysis. You know, it's mathematical computation is evident, but what do you mean by reducing the dimension of a matrix? If you think of it as an image, then perhaps there is some way of looking at it. But I would ask you, I have a small 4x4 matrix. To apply PCA and make it a 2x2 matrix, what does that physically really mean? I'm just out of curiosity asking what is your insight of that, so that I can also learn from it. It was a very nice presentation. Congratulations. I will look forward to your comment.
So principal component analysis is actually this is a you can have like if I tell you in the sort of a maybe x comma y plane, like you have a data in two planes or maybe x1 and x2 dimensions, and it's floated in the two dimensions of x1 and x2, and we are in this particular form where you are just finding a line to which you can project this values that lie in x1 and x2, and where you can like find a line where you can project these data points, and in such a way that you can get the most information about the variables that are present in that particular data set.
Okay, thank you. You know what I would additionally do to get a insight is to not just talk about x1, x2. You talk about something physical as the data. You know, something like mark or height or something like that. and then interpret what would happen if you do what you right now said. Anyway, thank you. I just wanted to quiz you on how you think about it. Thank you. Well done. A very good presentation.
Thank you, sir.
I have a question. Hello.
Yeah.
Yeah, like you are talking about subspace learning, right? You have given the details of image it has been. So what is like this algorithm? What kind of representation, data representation, distribution can be plotted so well that you can identify in the subspace, like plotting it and getting to know that this kind of representation goes wrong with this algorithm, and for this kind of representations it goes well. Did you get my question?
I'll explain from what I've understood. I've implemented this algorithm in the image space. I haven't looked much into where I could apply it for maybe tasks where I have data, regression data or other data that I have. I haven't implemented in that direction, but this is something I'll look forward in the next time that I present.
Okay, thank you.
Hello.
Hello.
Yeah, congratulations for an excellent presentation.
Thank you, sir.
Okay, one thing I would like to know that whether this looks to be a bit more than basic. Is it that this tensor algebra included in the under UG level syllabus for engineering, at least for computer science?
No, I don't think so, sir. We had to do this for a machine learning lab in our classroom, and for that we needed to study this tensor algebra. But it was just only a few parts of what is required is just being taken for this presentation. I haven't gone into much deep depth for tensor analysis. Just what is required for the HOI algorithm. That's just what I've shown in that figure. And if you want to extend it, I think so it would be much easier. Like if you want to write your own code or extend it into your domain of expertise, I think rather than implementing the code that I've also taken a code from someone else who has implemented it. But if you're going to implement it on yourself, I think if you get the idea behind how these tensors work and how these modern products are done, either you can do it by yourself, like in the like in the algorithm writing part.
That means it is like breaking a tensor, like that is what you have explained. That's what I understand.
Yeah, we are like reducing the dimensionality of the tensor. Like
okay.
If you put
So
it,
in this case, is there any alternate method like using these eigenvalues?
Like eigenvalues, this actually SVD when you go through like SVD, I didn't go too much detail of SVD and its implementation. You have the proper the process of finding eigenvalues and the process of finding this singular values. That is done in a very modular basis in the singular value decomposition. But when I told about this higher order orthogonal iteration, it is just like this finding this eigenvalue and all is a very like one of the sub problems that we have in this SVD. No, in this HOI, and that can this finding of eigenvalues and SVD and all these things are being done by these libraries that we have written, like SciPy or maybe TensorFlow. All these libraries have built-in functions that you just need to apply, and you can do these calculations. But for this higher order orthogonal iteration, we need to maybe there are no libraries yet, or maybe no direct implementations yet, because of the particular use cases that we need. And yeah, that is what is done. It is done in a modular basis, this eigenvalue decomposition.
That means these eigenvalues will anyway will decrease the degree of freedom, correct?
Yes, yes.
Doing this. Am I correct?
Yeah, this is like a higher order view, like a bird's eye view. Like you can use this in any order of tensor. Maybe SVD you can use it in a smaller matrix that form. But when you do it in this HOI, it is like in the tensor view of this point. Here, that's what.
This presentation requires some kind of a basic knowledge into this tensor algebra. So that is my observation.
Yes, sir. Like that tensor part is like more of the presentation rather than the algorithm. Like, tensor idea, if you have, then it will be very quick to get it.
Okay, congratulations. Thank you.
Thank you.
Thank you.
Speaker, we can call the next speaker.
Okay, ma'am. Thank you, Dan, for the wonderful talk. Now we have Rovina Mariam Jose, an MPhil computer science student from IIIT MK Technopark campus. She's completed MCA from Rajagiri College of Social Sciences. She has participated as a finalist team member in Smart India Hackathon 2018 at Chandigarh. Her publications include Deep Learning Models for Saliency Detection Review, International Journal of Scientific Research in Science and Technology, and Smart Farming via IoT, a solution for monitoring rice production, International Journal of Creative Research Thoughts. Is going to present on the topic visual saliency. Welcome, Rovina.
Hello, am I audible?
Yes.
As my screen is visible?
Yes, it's visible.
A very good evening to one and all here. Myself, Rovina Mariam Jose. I'm currently pursuing MPhil Computer Science from Digital University, Kerala. So for in the today's section, I would like to introduce topic visual saliency. So this is the overview of the presentation. Visual perception is the ability to interrupt the surrounding environment. So, in the human version, occipital lobe is the portion in the human brain helps in the human visual system. That is, while we see an object, it is captured by the retina of the eye, and which is converted to electrical signal, and which is passed over to the optical nerve and finally sends to the visual cortex, which is a region in the optical occipital lobe and forms an image. In this way, an image is formed in the human visual system. As we are in the new digital era and the introduction of AI, speaks to the introduction of the computer vision. Visual attention is a part of the computer vision. It is a process that enables the human visual system to select the most relevant information from the scene. That is, I request all we look at these images. So while just looking at these images, we are not capturing the entire image. That is, mainly all of you are focusing on these part of the images. And this part are known as the saliency part. And human and visual saliency refers to the part in which or the human how likely your human eyes will fixate on the certain part of the images. So, saliency detection means with the help of some image processing and computer vision algorithms to automatically locate the most salient region of an images. Saliency map. This output of the saliency detection is the saliency map, and it defines the visual locations in that image. As you can see in the figure, with our input image is transferred into a saliency map. Saliency map is also known as a heat map, where the outline refers to the region of the image where it have a big impact on predicting the class which the object belongs to. That is, where the gaze belongs to. The outline refers to the keyword of the eye gaze to. There are several applications of saliency, and some of the applications are in marketing, objective segmentation, WAPEX saliency, and medical. In marketing, saliency is the helps indicate over here a brand or what about or noticed when a customer is buying a situation. So it helps in buying a situation based on the customer's viewpoint. After segmentation, It also helps in the object segmentation, and it also helps in work page as while designing a work page, the designers can use this knowledge to create an interface that are easier in the customer search. And in medical field, it helps the medical purpose by making the affected area stand out in the foreground from the rest of the background images. These are the commonly used data sets for training the saliency model. And all these data sets are all this in this data set, all images are taken from the help of an eye tracker devices. Most commonly used eye tracker devices are Toby Pro and Island. And here next is we are discussing about some of the models, both the deep learning and the classical models used in the saliency detection. So SALNet is one of the model. It is trained by using two data sets such as ISIL and SunCon. And it consists of 5 layers, and it uses a fully convolutional network layer. It uses an activating function RELO, and with this is the architecture of the SALNet model. And with help of these layers, it finds out the saliency map. Next is a deep fix. It uses a VGG16 architecture, and that each block is followed by an instruction block, and which is then followed by an occasion LBC lab, which is for the fixation purpose. And with the help of this fixation and other layers, and saliency map is predicted. Next is SALGAN. It uses a generative adversarial networks. It consists of a generator and a discriminator. The image of SALGAN is shown in here. As you can see that it's considered an image generator and a discriminator. And by combining both, it forms a saliency map. Among that, it is an expandable multi-layer network. It consists of 2 stages. It uses, for encoding, it uses more than 2 CNN model. And at the encoding stage, the encoding and the decoding stage are combined together to form the saliency map. Next is saliency using natural statistics. It uses a Bayesian framework, and it estimates the saliency map with the help of some probability methods. GPVS, it is a bottom-up visual saliency model. It is a graph-based visual saliency model. It's extracted by using a feature vector matrix at the location of the image plane. It forms an activation map, and the activation map are normalized to form the saliency map. The SUN and GBVF model both are the classical models. So this uses the deep learning techniques, and these are the results from all of this model. Evaluation metrics. In order to evaluate a model, we use the evaluation metrics. That is, comparing our saliency map from the model to the ground truth and finding the similarity, how much similar the images is. And mainly using the evaluation metrics is a normalized scan-path saliency, linear correlation coefficient, and similarity metrics. The normalized scan-path saliency helps to, if the output is negative, it shows that similarity is very less, and if it is positive value, it shows the similarity is high. And linear correlation coefficient compares the correlation between the ground truth map along with the saliency map. And the linear correlation coefficient and the similarity metrics values are between 0 to 1. Minus 1 to 1. So these are, as you, from the table, it is clearly visible that there's GBVFs and SUN saliency. This display uses any deep learning techniques. As compared the value, the other deep learning models are high, performance is high as compared to the classical models. So, as I conclude, vision in general and in images is particularly for an important role in human life. And visual saliency is seeking out the gaze point or where the human eye is willing to fixate in certain area. And visual saliency is a very great active research area over the last few years. There are several models have been developed to find this visual gaze in it, and these all are represented by saliency map. By comparing the classical models along with the deep models, and On the basis of large evaluation metrics, the deep model performs much better than the classical models. And that's all for the session. Thank you.
Okay, Rovina, the data sets you have mentioned, do you have the source of the data set? Like, what are the data sets? How many images in use? And about particularly the SALGAN, the Generative Adversarial Network, can you discuss about the data set used in that model?
Okay, ma'am. Ma'am, once again. Pardon, ma'am. Ma'am, can you ask the questions once again?
The data set source, is it downloaded from Kaggle or?
Yeah, ma'am. Data sets are available in Kaggle. We get readily available data sets, and in Salcon, the Salcon data sets have been used.
Okay, so all these are pre-trained models, right? Yeah, we can do transfer learning, I guess.
Yes, ma'am.
So you have done the performance comparison, right, of these pre-trained models?
Yes, and yes, ma'am. And then the comparison of deep models along with the classical models.
Okay, that's all. Questions
Yeah,
from participants?
I have one question.
Yes, sir.
Hello.
Yes, sir.
So the models are to predict, for prediction, right?
Models are used to generate a saliency map, which predicts in salient regions. That is where the eyes will, where the humans look will most likely to be fixate in the image.
So is there how do we compare with the actual data?
Um, Compare with the
In the sense, when we have a theoretical prediction, we should be able to compare, no, with the actual values.
we have a ground truth database. Data available along with in the database, and we compare the ground truth image with the saliency map generated from the uh, these models.
Okay, so do we have some fit?
Yes, sir.
Like, will you be able to say that this much percentage it is correlated like that between this theoretical and actual?
Yes, ma'am. Yes, sir. Um, as we compare with the help of this evaluation metrics, actually we are just comparing the ground truth images along with the saliency map predicted from that, and we are just calculating and finding the correlation between the similarities.
Okay, fine. Thank you.
There is no more queries. We can move on to the next person. Now we have Aishwarya S. a BTech student of Luthmada College of Science and Technology. She has participated in Reboot Kerala Hackathon and she is placed in TCS. Apart from the academics, she is an All India Radio B grade artist. Now she is presenting on the topic a literature study on machine learning fusion with IoT. Welcome, Aishwarya.
Thank you, Neetu. I hope my screen is visible.
Yes, yes, it is visible.
All, my name is Aishwarya. So the topic I'm going to discuss is about a paper titled "A Literature Study on Machine IoT, then Applications." The main thing in machine learning IoT is data. Data is nothing but information which can be obtained from different media such as social media or different databases such as transportation, communication, etc. This data will be in the raw form. We have to clean and process data so that it will become more relevant. This relevant data can be used to develop IoT and data science applications. Internet of Things is the interconnection between these physical objects through internet, which establishes a communication. IoT involvement is increasing in the base of the data generated. Machine learning. In machine learning, we perform computations with enormous amount of data available. This process is called training. We train machines, and this repetitive training refines the ability of learning and decision taking of that machine with respect to the applied algorithm. So more on to machine learning. There are a lot of algorithms available in machine learning. We can use that to implement different models. Mainly, machine learning is categorized into 4: guided, unguided, semi-guided, and reinforcement. In guided learning, we know the labels or the output data is already known. In unguided learning, we don't know the output data set. It classifies based on the similar attributes. In semi-guided, it is a combination of guided and unguided. And reinforcement learning, the machine takes decision based on the mistakes. So in supervised, classification and prediction happens, and in unsupervised, clustering and association happens. So this is just an example how a machine learning program works. So the data set will be in the form of a Excel file or a spreadsheet. This is just an example of an Excel file. It has place at a particular place, how many persons are in total there, and how much percentage of people there are affected with a particular disease. This is the data. We are importing this data into the code. I've written code in Jupyter node. There are a lot of software applications such as Eclipse, PyCharm we can use to write this. So I'm importing my data set into the code. And the desired output is I need a graph that's showing how much with the increase of number of persons at a particular area, the chance of increasing the spread of diseases at the area. So next is Internet of Things. As told, Internet of Things is the connection of devices through internet to establish a communication. And these devices, we call it as IoT devices. The main devices available are Arduino device, Intel Galileo, Raspberry Pi, Samsung Gearfit. It is just like Samsung Gearfit is just like a smart band. Then the IoT platforms available are AWS IoT platform, Microsoft Azure platform, Google Cloud platform. These provide resources to develop applications. So this is just a sneak peek of how this interconnection with these devices happens in IoT. So Blink is an application which we can download from our Play Store. It is available in both Android as well as iOS. So I have downloaded Blink and I've registered my mail ID. And in order to create a new project, I can click new project. When I'm clicking new project, I have to give a project name. Here I have given it as trial. Then I have to choose a device. Here I have chosen Arduino Uno. The hardware I have to choose. And yeah, this is how, and the connection type also we have to specify. Here I am given as Wi-Fi. Now, when I click create button, an auth token will be sent to the registered mail ID with which I have created this Blink account. In the mail ID, the auth token will be in this form. I have to copy this auth token and paste it in the IDE. This is how it interconnects. And in Blink, there are a lot of features available in the widget box. Initially, we'll be having a certain amount of energy balance. Here I had 2000 something, and with that I can purchase the features available in this. If we want more, we have to pay and buy. If I'm here, I have used button. When I'll be clicking button, an interface like this will be opened. In button, I can select the pin of the hardware to which I'll be connecting. Then again, I can work this button as a push button or a switch. So likewise, we can provide features or according to our requirements. So the existing applications, it is a ubiquitous health monitoring system based on anomaly detection of diseases at early stages. This health monitoring system takes data from an individual and analyzes and understands that if there is any chance of a disease that can occur to that person, and which can be detected at the early stages, and the life of that person can be saved at the correct time. Then in Malaysia, they have used an IoT sensor device to collect data with respect to which they analyze conditions of the road surfaces in Malaysia using supervised learning. And the projects that we can develop with IoT and machine learning combined together is a smart example. The smart agriculture system. Camera sensors can be used to capture images of leaves, and algorithms can be used to classify whether that plant is having any disease or plant is having any problem. And likewise, smart agriculture system can be developed. Then flood detection. The weather can be analyzed using these IoT sensors, and we can analyze that is there any chance to occur flood in that area. Then smart parking system or smart traffic system, using IoT devices and machine learning together, we can analyze whether a vehicle coming in a particular speed can hit another vehicle or not. Then smart anti-theft system, night patrol robot, health monitoring system. All these are examples of projects that can be developed using the combination of machine learning and IoT. So, at last, all in all, we can tell that when the output of IoT devices is data, and the input of IoT devices, input of machine learning is data. If we are combining both of them, then the projects develop will be more efficient and less time-consuming, and the results will be very much accurate. So this literature survey ensures that machine learning and IoT together provides more intelligent decision making with respect to smart data extracted from the data generated by various sensors and devices. It clearly explains how it can be a wonderful source for data sets. These are the reference. That's it. Thank you.
Yeah, Shudhira. Like, is it integrate ML algorithms into it?
Sorry, ma'am. It wasn't audible.
We discuss about the capabilities of the Blink server. Just UI designing.
Sorry, I didn't get you, ma'am.
About the Blink app you have mentioned, right?
Yeah, I have mentioned.
Yeah. What are things you can do with that? Can you integrate machine learning and algorithms in that? You have mentioned some.
Blink is actually used to interconnect IoT devices. We can control IoT devices. We can control devices with the help of that app.
So, is there a way to integrate ML algorithms into it? Have you checked on that?
I haven't gone through that, ma'am.
Okay, so the components that you mentioned, did you build any prototype and checked out how it works?
I haven't built one, but in my previous semesters, I have attended a workshop and a hands-on workshop, and I've tried out that.
Okay, Shari. Open to audience.
Can move on to the next talk. Let's sit down for the last talk of the session. I invite Vijay Joy, a BTech student of Lutmada College of Science and Technology. She's participated in expository and literary competitions. She was college junior member and class topper. Also, she was an active NSS volunteer. Now she's going to share her views on the topic digital jewelry. Welcome, Vijay.
Thank you, Neetu. I hope my screen is visible. Hello. Yes, it is visible. Okay. So, good afternoon, all. I'm Vijay Joy of Lodmada College of Science and Technology, and my today's topic is digital jewelry. In this presentation, we will go through the small topics on this main heading. That is, we will go through the introduction, then what is a digital jewelry, components of digital jewelry, then what are the features, then technical specifications, and etc. So, first of all, introduction. We all are wearing a jewelry. It's not about our age or or if we are a girl or a boy or a small child or elder person. It's not matter that all are wearing jewelries, and we are wearing the jewelries for the purpose of aesthetics or as a symbol of affiliation and commitment. We are wearing lots of and huge jewelries. Then why can't we make it some useful thing? That's the point where this topic comes to an importance. That is digital jewelry. It is a combination of microcomputer devices which have embedded intelligence in it. That is, digital jewelry is the fashion jewelries with embedded intelligence, and they are wearable. That is, we can wear the digital jewelry in our body as similar to wearing other jewelries also. And what is a digital jewelry? A digital jewelry is a small electronic device that are designed as fashion jewelry and are embedded with intelligence. The features of digital jewelries are digital jewelry helps us to save our passwords. Nowadays, we are using lots of password, and there was some situations that we forgot our password, and there is no a way to access our systems or something like that. And digital jewelry helps to store our passwords, and it can be used as all-in-one replacement for all the documents which we have. And coming to the components of digital jewelry, the main components of digital jewelry are ring, necklace, bracelet, and earrings. So the main idea of digital jewelry is to divide the parts of a large cell phone, like a battery, circuit board, antenna, microphone, etc., into small components and embed them into a jewelry which we can wear, and we can use it as a complete cell phone. And a company named IBM, that is an International Business Machine Corporation, it's an American company. They have designed a prototype of a cell phone. They divided the cell phone into small parts and embed the cell phone into the jewelries. And all these parts work together with the help of Bluetooth technologies. Nowadays, this company is working on a miniature rechargeable body battery to power these components. The components are earrings. The earrings can be used as the speakers or receivers of these phones. And the next component is necklace. And this necklace can be used as the microphone of the mobile phone. And coming to the next component, it is ring. That is the finger ring. We can use this finger ring in such a way that it contains an LED which will flash when a call comes or an email comes, and it can be programmed in such a way that it will flash on different colors, which shows the importance of the call. The next component is bracelet. The bracelet consists of a videographic array display. That is, we can place it on the wrist of our hands, and and it can be used as a touch screen or a keyboard and dialing function. It consists of it have the functionality of the screen of a telephone of a mobile phone. So these are the pictures of the pictures of the digital jewelry components. The first is the earring. Next is the necklace, which we might have seen in some picture films. Then next is the finger ring. Then and next is the bracelet. Then coming to the features of digital jewelry, the main feature is it is portable. That is, we can wear in our body and we can carry it all the places we are moving because of its small size. And next is it consists of sensors. This sensors include cameras, microphones, and sometimes it may have sensors like temperature sensing sensors. And the next feature is it is always on. That the device is always on, working, sensing, and acting. Then next is use retention fee that free. That is, we don't have to give much attention to these devices. Then it is communication. These devices will always communicate with the user in respond in available times. Next, about the technical specifications and digital technologies. While considering the screen or the bracelet, it consists of 7 to 16 segment LED or dot matrix LCDs. This 7 to 16 segment LEDs we might be familiar with it. That is the older times calculators consist of it, and this dot matrix LCDs and LEDs are available in the KSRTC bus boards. So we might be we all are familiar with it. These displays are placed in the bracelet, and it may have external switches and buttons on it. Then prototype bracelet by IBM. We have told about a company, and that is the IBM, and these companies have created a prototype bracelet. These bracelet can be used to make phone calls, and it will also help to send emails. This company have converted the track point technology into the track point technology, which is used in the computers, which are more useful to locate the locations on the screen in the systems. And this company have transferred this track point technology to a ring, which look like a small black ball. This is the image of the prototype bracelet created by IBM. And this technology is very useful to track the positions very correctly, because when we consider about the digital jewelry, the monitors are shrinking to the to a watch face, and or the screens may be shrinking to a sunglass. So this track point technology will help us to locate the positions very correctly. Next is the Garnet Ring. The Garnet Ring is a ring with microprocessor and vibrates when a message comes to let the user know that there is a message. And this is the image of the Garnet Ring. And next is the Java Ring. This is the main component of this this digital jewelry. The Java Ring is a small microprocessor. Actually, first this ring was introduced at a school, and the ring which is programmed with Java applets are given to the students. When these rings are snapped into a reader called a blue dot receptor, this will communicate with its host, and which will help. Java ring consists of this Java ring is a ring which has 134 KB of RAM, 32 KB of ROM, and it have a real-time clock, and it have a Java virtual machine which works fine in this ring. And this ring, this the image of this ring. And to say about the functionalities of this ring consists of a card named Java Card 2.0, which is embedded in this ring. And this main use is to unlock our systems, and it is very useful nowadays. Next are the advantages of the digital jewelry. The main advantage of the digital jewelry is security. If we forgot the password, no problem. If we have a digital jewelry, it will help us to unlock our doors and systems. And these are digital jewelries are embedded in our jewelry, so we don't have to carry a system separately. And it is wireless wearable technology, and it supports dynamic programming, high durability, and it will function in harsh temperatures, that is from -40 to 70 degrees Celsius, and mainly it provides protection for girls. As the system has these much advantages, it may have some disadvantages also. That is, its charging capabilities. That is, it's small device. We have to charge it, and it is very cost because it is in an upcoming stage, so it's very costly now. And the display is small. So with that we have come to the conclusion, that is, this wearable devices are in a growing stage. That is, after sometimes, that is, if after 20 or 30 years, all our large systems like laptops and mobile phones might shrink to small digital jewelries which we can carry through without while we are moving, walking, and etc. It can be designed to supplement the personal computers in our day-to-day life. And these are my references, and that's it. Thank you.
Okay, Biji, is the Java ring only for access control? What any other functionalities?
Mainly, it is used to provide access to our systems.
Yeah, that's what I meant, like access control, right?
Yeah, ma'am.
Okay. And any idea about the cost and all?
No, ma'am. It's not given that journal. It's given that it is costly because it is in an upcoming stage, so it might be very costly nowadays.
Okay. Okay. That's all queries from the participants.
Yeah, so I understand one of the main disadvantages that if components it's not like an integrated system. So that is going to be a cumbersome act, I think. And second thing is that, okay, this is a different concept, but nowadays the mobile phones are coming wherein there are proximity sensors, wherein the owner comes near the mobile, then it is possible to unlock from where the systems are coming up in the new mobiles without
Yes,
even putting that fingerprint.
Yes, and the main advantage of this digital jewelry is that we don't have to carry all mobile phones or laptops like that. All the systems are divided and are integrated into our jewelry, so that we can wear it as a fashion jewelry.
Yeah, that's fine. But see, finding these charging these small devices is going to be an issue. And,
yes, and this company, that IBM company, is nowadays working on miniature batteries to power these devices.
And second thing is that we have to see to it that all the components should be charged, and only it will work with all functionalities. Correct, no?
Yes, sir.
Yeah, if you have an integrated system, we have to just charge that. But in this case, we have to charge. Let us say there are 6 parts. All these 6 components we should charge. Then only we'll be able to use it.
Yes,
completely. Anyway, it's a new concept. Congratulations.
Thank you, sir.
Yeah.
I guess there are no more queries. Neetu, can we conclude the session?
Okay, ma'am.
Okay. So, come to the end of this session. The first talk was by Dan Matthews Robin from IIT about the HOI algorithm for tensors. The second one about the visual saliency and the deep learning models by Rovina Mariam Jos from IIT. The third talk was by Aishwarya S. from Lodmata College of Science and Technology, who gave an overview of ML and IoT. Then the last one by BG Joy, who gave an overview about the digital jewelry and the use cases. So all the presentations were very nice. Congratulations to all of you. And I would like to thank CSI Trivandrum chapter and students chapter, Lodmata College of Science and Technology, for inviting me to share this session. Thank you. Thank you all once again.
Thank you, ma'am. I would take this opportunity to thank Dr. DTPS ma'am for your valuable presence and feedback about the session. I also thank Dr. Elizabeth Shirley ma'am, Dr. Bijay ma'am, and Jisha ma'am, CSI Trivandrum chapter for giving an opportunity to coordinate this program. I place record of gratitude to all the wonderful speakers from IIIT MK and LMCST for being part of this session. I thank LMCST Principal Dr. P.P. Mohalal sir, Dr. Bishiba Wilson, HOD CSE Department, CSI Coordinators Professor Ashita ma'am and Professor Ambule ma'am, and LMCST family for their support towards this program. Finally, I thank all Kerala CSI members and all participants for being part of this program. Thank you all.